Good afternoon, everyone. I'm Shlok Gilda. I'm a PhD candidate at the University of Florida. And it's great to be here to present my ongoing PhD work, which is predicting OSS vulnerabilities through communication analysis. So a little bit about me. The focus of my PhD is sort of on the human side of open source security. We as a community spend a lot of time on bug detection, which obviously is pretty important. But my research tries to focus on a different aspect, which is it centers on the communication dynamics that often precede and enable these security vulnerabilities. And I want to be clear from the start that this is not a product pitch. This is my active research, and I'm here to get community feedback from experts in the field. Hold on. Right, yep. So we are all familiar with the headlines. Two recent attacks really highlight the human cost of these attacks, which is the XZ attack was a near global catastrophe, rooted in social engineering and classic maintainer burnout. And in the event stream attack, back in 2018, from what I remember, yep, a trusted relationship was exploited to steal cryptocurrency from millions. And these weren't just technical failures, they were essentially human failures. So what is the common thread that connects these incidents and so many others? I think the answer is right here in this quote from Lasse Collin, the original maintainer of executals. What's going on? Yep. So, yep, he said, my ability to care has been fairly limited. This is an unpaid hobby project. And this isn't just a comment, it's essentially a flare-up sent from the front lines of a project which was under immense stress. And that stress creates the exact vulnerabilities that malicious actors look for. It leads directly to maintainer burnout. It opens the door for sophisticated social engineering. It causes critical warning signs to be missed. And it's often rooted in a lack of open communication, which was a common aspect in both the executals as well as the event stream attack. And this brings me to the core question that's driving my work. Can we learn to spot the warning signs of the next supply chain attack by analyzing a project's public conversations? And I believe the answer is yes. My approach is a methodology I call the FORCE, Star Wars reference, heck yeah, short for Framework for Open Source Risk and Community Evaluation. It's an integrated system that analyzes 3 key data streams to get a holistic view of a project's health. First, we analyze all public communications, whether be it GitHub pull requests, issue comments, or mailing lists. Second, we are also looking at contributor network, which is essentially how can we map contributor network, who takes a more central role in a project, who is sort of on the sidelines, what sort of work, how are these relationships between contributors and a project maintained, and how do they improve. There's another thing, which is vulnerability metrics. I'm not going to focus on that much in this talk, but feel free to reach out to me to discuss that after the talk. And at the, so these inputs are then processed by a lot of these analytical engines, sort of. So we run communication analysis using techniques like sentiment analysis and toxicity analysis to decode the words and the emotions behind them. Simultaneously, we run network analysis to quantify the project's centralization and its statistical risk. And the ultimate goal is to sort of generate a temporal health score, which think of it as a check engine light for a project's health. So the idea is to combine signals from all of these different analytical engines to come up with a health score that can be used to determine a project's health. So let's break that down. Step 1 is decoding the words. First, sentiment analysis tells us if the emotional tone of discussions is trending positive or negative. Are people happy and collaborative, or are they frustrated? Second, we go deeper than just positive or negative with toxicity and outage detection. This is crucial for distinguishing between constructive technical criticism and genuinely harmful or intensely frustrated language that can signal serious community distress. And even within toxicity detection, one of the works that we worked on was trying to identify subtle toxicity detection. So it's not something that's outrightly toxic, but sort of like an unfair generalization, or if you can identify some sort of criticism against not the work, but the person, if that makes sense. So that's one of the things that we've been also looking at. And finally, topic modeling helps us understand what people are actually talking about. Are the discussions about new features, bug fixes, or are they shifting towards more contentious topics around securities or dependency fixes? But words are only half the story. We also need to understand the relationships, and that's when network analysis comes into play, where it helps us map who is talking to whom within the project. This can reveal who is a central, influential figure, who is becoming isolated, or if the community is breaking down within, if the community is breaking into factions. And crucially, stance detection tells us if people agree or disagree on key issues. So, measuring community consensus or conflict. Are contributors supporting, opposing, or are they neutral on significant changes or discussions? And this gives us direct insight into the health and cohesion of the community. The vision is to bring all of this data into a fever chart for a project's health. The key output of the framework is this Temporal Health Score, as I earlier mentioned. It's a single time-varying metric that quantifies the overall health and the security posture of an open source project. Think of it as as a predictive early warning system. This is again a hypothetical chart, but it shows how the score might fluctuate over time. You can see that the dips correspond to events like a major vulnerability disclosure followed by periods of intense community discussion. And the goal is to give maintainers a simple, actionable indicator of their project's health before a crisis hits. Importantly, this health score is not meant to be a black box. If the fever chart shows a dip, you as a contributor or a maintainer needs to know why. And to provide this transparency, we use something called as Shapley values, which explains the outputs of our model. The chart shows a hypothetical example. So if you look at this example, rising toxicity or negative sentiment are the most significant drivers. In a different project, the key factor might be network centrality, which could suggest that a key maintainer is becoming a bottleneck. And this interpretability is essential for making these insights actionable. Again, this is the theory, but what happens when we apply this exact methodology to the biggest supply chain attack of 2024? Let's look at the data, because the evidence of the XZ attack is clear and it's measurable. We see two distinct signals that, when combined, tell us the whole story. Let's first focus on the red line. I'm not sure if, yep. Okay, let's just focus on the red line first. The sharp spike you see in mid-2022 isn't just some random noise. This is the data visualizing a targeted psychological attack. We know that suspected sock puppet accounts with names like Jigar Kumar and Dennis Enns began publicly pressuring the volunteer maintainer, Lasse Collin. Their goal wasn't just to complain, it was to manufacture a crisis of sorts. They used entitled and demanding language, sending messages like, progress will not happen unless there is a new maintainer. So the whole idea was to specifically wear down the sole maintainer and create a social pretext for a new person to step in. This was an acute, weaponized social engineering attack. Now let's look at the blue line. Look at the values on the right-hand side, if that makes stuff easier to understand, I guess. So the blue line measures project centralization using something called as the Gini coefficient. The Gini coefficient is a concept from economics, originally used to measure wealth inequality. A low score means work is spread out evenly. A high score means one person is doing almost all the work. What's fascinating here is that the Gini score for the XZ-Utils project starts high. That itself was a huge warning sign. It tells us that the project was already dangerously centralized around its sole maintainer. This pre-existing structural vulnerability is exactly what the attackers targeted. Now, logically, when a new maintainer joins, the score, you would expect the score to go down. And you do see this small dip over here, starting in early 2022. Let's call it the honeymoon period, where on the surface, it looks like a healthy collaboration between GRTAN, which is the name of the malicious contributor, and Placer Colin as GRTAN starts making his first contributions. But then look what happens right after he gets full commit access in Jan 2023. Though score doesn't just go back up, it skyrockets up. And this isn't collaboration, this is essentially consolidation. GRTAN isn't just helping, he's actively taking over, pushing the original maintainer out and making the project even more centralized than it was before. And the rising blue line is essentially the data showing the structural takeover in progress. It's the quantitative evidence of a slow 3-year-long chronic attack that exploited and then worsened the project's already existing structural weakness. I do want to say that neither of these signals alone is a smoking gun. A toxic comment could be a one-off. A highly centralized project is a risk, but not necessarily malicious. But the sequence is what matters. A social pressure campaign that creates an opportunity, followed by a hostile actor exploiting that opportunity to centralize all control. That is the powerful, actionable warning sign of a sophisticated supply chain attack. Again, all of this is research and still work in progress, but my vision for this project sort of is, where does this research go from here? And the idea is to a 3-step path from research to reality sort of is, start with a simple command line tool for maintainers, evolving that into a GitHub app for real-time monitoring, and finally building a comprehensive dashboard for long-term strategic oversight. And this brings me to my final point and my real reason for being here today. This can't be built in an academic bubble. I've built the initial data pipelines for sentiment, toxicity, topic modeling, and network analysis. We also have a pipeline in place that can analyze vulnerabilities for a given repository over time. The immediate focus is on building a robust stance detection model, specifically for open source discussions and rigorously validating the actual full temporal health score. And this is where I need your help. First, I need your feedback. Is this project really useful? What metrics you as maintainers, security professionals actually care about? Second, I need data. What are the projects, both healthy and compromised, could be great test cases? And most importantly, I'm looking for collaborators. So I'm looking for maintainers, security researchers, tool developers to help me refine and shape this project into something that has a real impact and is actually usable by the community and for the community. Thank you. I'd be happy to take any questions, and please feel free to connect with me. Please feel free to connect with me. Thank you.
Time for
You talked about handling sentiments and all. So how are you planning to handle false positives?
That's a very good question, and I really don't have an answer for that right now, unless, it's an open problem in the community. I agree, handling false positives, because a lot of the work that we are trying to do, it's not a general model. It's a specific it's a model that we have made sure that is specific to the software engineering community. So we have noticed that model performs better in software engineering discussions compared to generic sentiment detection models. So the number of false positives are fewer, but that's still a case. And the idea, and that's where the whole system design sort of comes into play is that we are not just trying to focus on just one sentiment detection model, but there are other models as well. And so the hope is sort of that the false positive for one model might not be might not might be sort of subdued by some other better signal from a different model.
You can definitely use the Linux kernel mailing list for catching false positives.
Yeah, that is definitely one of the things that I'm going to do. Thank you.
Oh, no, sorry. Well, okay. Excellent talk. Sorry, I came in halfway through. Did you do any analysis to see if the Jian Tan was actually one person or multiple people writing?
No, haven't done that analysis yet, but that's definitely something that we can do.
My assumption is that there were several people were doing that, and it was a load sharing thing. It would be really useful to look at the language style and see if you can detect different people behind that. Because I'll lay dollars to donuts that there was more than one person behind that.
That's a good thing. Yeah, definitely we could look into something like a stylometric analysis to sort of compare the language styles of the sock puppet accounts as well as the Jiatan account. So that's a good point. Thank you. I didn't think of that. Thank you.
First off, this is brilliant. I mean, the three of us are sitting here, giddy. Yeah.
Thank you.
There was a beautiful moment where you had your chart of the Jiatan piece, and the three of us went to our phones at the same moment, and you got all three of us trying to get a picture in. Both of them in my way. I couldn't get my picture.
Thank you.
I wanted to reinforce a couple of things you said that as you're talking, I was like, oh God, he's going to make this mistake, and you didn't, and so I loved it. First one is, I'm really happy to see you're looking at change in state. I would encourage you, pulse, not health, because some communities will be more toxic, and that's fine, because it's a measure, right?
Right.
Sometimes it will be cultural, sometimes, and it's the change that is fascinating, when it suddenly changes dramatically. I also love that you flagged every negative could be someone else's positive, right? Sometimes these are just good things. I really loved how you dug into, yes, it looks like things are great in the Jiatan scenario, we're getting more activity, but you're actually identifying that there's a taking over, seizing control.
Yeah.
This is just, I want to point out, you were great, this is awesome. The one I wanted to throw you as something to think about that I've noticed when I'm looking at a lot of projects, when you see users, and this is often I'm looking in the corporate-owned project perspective, so it makes a lot more strength sense here. When you see users starting to answer each other's questions on GitHub in the issues, on one hand, this is brilliant, this is community building. But when you're seeing that the people who have maintainer rights, who are committing, are no longer involved in those conversations, your user community is not attached to your developer community. And I think that's one of the things I've been able to see as I've got a problem here. Like, someone's not being fulfilled, and they're starting to fulfill their own needs. And so over time, you're going to see this kind of scenario. So I'd look into that network effect as well, your users talking amongst each other, and what the roles of people are.
Yep, that's a good point. And to that end, there is some sort of work that I'm doing with a collaborator of mine from Texas A&M University, where we are trying to look at the difference between core contributors versus peripheral contributors, if that sort of makes sense. So and with regards to even just the score thing, I agree, it should sort of, it needs to have a baseline for a given project or community, and then you just look at changes based on that. And to that end, one of the things we are still trying to figure out is how do you assign weight to certain contributions, or core contributors should definitely get a higher weight when it comes to certain things. But it's just the idea of there's so many different aspects to within an open source community that how do you even where do you even begin to start assigning those weights to what use cases? Because sometimes you have maintainers who might not be very active on certain days. They are active on some other, they are working on some other duties. They are still maintainers. So how do we even figure all of that stuff out? So all of these are still open questions, but thank you for reinforcing that point. That's really important. Yeah. Yeah. Yep. Right. Yep. Thank you.
So it looks like a lot of your work has been focused on projects specifically. I'd be interested if you've thought about or have started applying it to things like special interest groups within foundations like OpenSSF TAC or Confidential Computing Consortium Outreach, because they also have problems, and knowing ahead of time that something needs to be done, particularly if there are lots of different ones, would be an interesting thing to do. And particularly if it could be automated. We will typically record our meetings so that there's quite a large corpus of stuff that could be analyzed. So yeah, just another thought on Slack and email and all those sorts of things.
No, I didn't really even, I didn't think of that, but that's a good point. Thank you. I'll keep that in mind. Thank you. Yeah, thanks.